Hello Year 13. This is a short video on compound angle formulae. Now I hope you got a chance to see the other video which I posted showing you a proof of these 6 formulae, and I know you're probably looking at that thinking there's only 3 there. Well, I count 6 because each entry, isn't it? When you've got this plus and minus, that's saying, well, there are basically 2 formulas hidden there, 2 formulas hidden here, 2 formulas hidden there, and I'll say a bit more about that in a second. But yeah, I mean, they're in the formula book. I want to make that clear straight away. So there's a bit of good news for you. The one bit of good news, they are in the formula book. But I do want to draw your attention to something, which is that when there's a plus or minus over here, and there's a plus or minus over here, the top one goes with the top one. So that plus goes with that plus, and that minus goes with that minus. In other words, you can simple, and I'm just going to write this down underneath, sine of A minus B is sine A cos B, sine B. Yeah, so the minuses go together there. However, if you look at the cos formula, look very carefully, and that plus minus is switched to a minus plus. You see, you've got to read it in the right line. So, for example, cos of A plus B, cos A cos B minus sine A sine B. Yeah, so read it along the same line which it sits in. There's a top formula and a bottom formula, if you like. And just one more bit of practice with that. Notice with the tan formula, tan A plus or minus B, well, that's tan A. Oh, sorry, let's do tan. Let's pick one. Let's do tan A plus B. That would be tan A plus tan B. Sure. But then over 1 minus tan. How that works, because we have to pick the top ones for the plus. Top, top, top. Okay, so that's the compound angle formulae. The video which I posted up of the proof, I really like that way of proving it. I love that way of proving it, to be honest. That's the way I always prove it, and I stole that proof directly from the maths teacher doing that video. I thought it's such a lovely way of proving it. I'd seen other ways before, but I just really like that approach. So I hope stand the proof. Will you be asked to prove it? It would be quite surprising if you were, actually. They've never done it before. Could formula book, and they do emphasize proof, but my guess would be if they do get you to prove it, they'll show you a bit of the diagram, and they'll and ask you to add a bit more. There is another very common way you see it proved as well, actually, and if you want to look that up online, if you look for any other compound angle formulae proofs, you'll see another typical way of proving it, where you've got like a triangle on a triangle like this. Two right. My drawing is getting worse. There's another very common way of proving it. Let me just show you, and you can look this up online. There'll be tons of videos on this, because it's the way you used to see in all the textbooks. These are 2 right-angled triangles. They're supposed to be right-angled anyway. So let me just put in the little right angles. That's a right-angled, and that's a right angled, and then they drop a line down here, and you can prove it using this diagram as well. I fully invite you to yeah, take a look at that. You get a compound angle, of course, because you get an angle here and an angle here. But yeah, maybe I should quickly have a go at proving one of the formulas like that. It would be quite good fun, perhaps. But no, I don't think I've got enough time in this video. But challenge me in lesson next week to prove it like that, because I'd love to have a go. I can't remember exactly how it works, but it's not that difficult, is it? Okay, so why do we use the kind of talk about in this video? Why do we use it? Well, I mean, there can be a number of different types of question which they can ask you to do here. A fairly typical one would be something like this. Express sine of 75 in exact form. So we're back to degrees, and yes, these formulas do work in degrees and radians, whichever way you want. Well, the way to do this is to think, what known trig angles are we supposed to know? And the answer is, well, 30 and 45. Those adding to make 75. I suppose I could have used taking away, but I guess it's easier to think of adding. And then we can just do, okay, sine 30. Look, the important thing is, by the way, lots of students think that's just the same as sine 30 plus 40, sine of 45. Sine is not a number. You can't multiply out brackets with sine. That's the whole reason we have these compound angle formulae. So that is definitely not true, yeah? And you can see it's not true. Well, this is going to give you a half. Sine of 45 is going to give you 1 over root 2. And you'll see basically that that is not the same as sine of 75 when we see the answer in a second. It just doesn't work like that. So you must use the compound angle formulae whenever you're presented with a compound angle, basically. And so what do we have? We have sine 30 cos 30 cos 45 plus cos 30 sine 45. Okay, so then we've just got to work out, well, that's a half times by 1 over root 2. And then cos 30 is 1 over root 3 over 2, sorry. Ooh, times by 1 over root 2. And so we end up with 1 plus root 3. Your calculator will often give you this exact. If you type in sine of 75, I think your calculator, let me see, I'm going to test it on my calculator. If I type in sine of 75 when I'm in degrees, must be in degrees, angle unit degrees. If I type in sine of 75, does it give it exact? Yeah, it does. Now my calculator tells me it's root 6 plus root 2 over 4. I think that's the same answer as what I've got here. Because if I now, and you wouldn't have to do this, we've expressed it in exact form now. You could leave the answer like that. But just to prove to you it's exactly the same answer as the calculator, if I times top and bottom by root 2, you're going to get root 2 plus root 6 over 2 root 4, and that's the calculator answer. So there we go. We can now express it in exact form, and we can show that that's the exact form. So that's one possible question, one possible example where you might need compound angle formulae, but there are many more, many more. Okay, let's try, what about this? What about if it said solve, yeah, let's do this one. Solve, if we have cos x cos 60 sine x sine 60 equals root 3 over 2. Okay, so we're going to try and solve this. In fact, I might even make that, no, I'll leave it as it is. And you've got to have a range when you're solving for 0 to 360. Should we say 2 pi this time? Make it a bit of fun, bring the radians in. Yeah, why not? Let's bring some radians in. I think actually in the exercise they seem to be all in degrees, but I want to remind you that radians, no, actually there's a couple at the end of radians, but yeah, let's do it in radians. Okay, hopefully you can see that that is the compound angle expansion for cos. Can you see it looks just like cos A cos B minus sine A sine B? And when it's minus on the right hand side, it's plus on the left hand side. So what we could do is we can immediately simplify the left hand side of this equation to make cos of x plus 60. Oh, I've realised I'm using degrees in the question, and I'll have to change this to 360 now because you can't use degrees there and radians there. That's just silly. I'm sorry, I am making these up off the top of my head. I apologise. Okay, so cos of x plus 60 must be root 3 over 2. Now it's easy, just do inverse cos of root 3 over 2. Inverse cos of root 3 over 2 is, well, sine of 30 is a half. So, cos of 60 is a half. So cos of 30 is root 3 over 2. So this will be 30. Now, the temptation obviously every time here is to just immediately subtract 60, but that is not what you should do. Yeah, remember, rules of thumb for sine, cos and tan. We immediately do 360 minus that and we get 330. You can look ahead and think as well, I'm going to take away 60 in a second, so this one is not going to be in the range anyway, but then add another 360 to it, you get 390. And then, you know, put dot, 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 further solutions there. But the only two which are going to be in our range are 270 and 330. Yeah. Now, I would always, at the end of it, check my answer by plugging those values in and seeing if they genuinely do equal root 3 over 2. So I'm just going to press cos 270 cos 60 minus sine 270 sine 60. And I get root 3 over 2. I'm so confident in the second one that I'm not even going to check it. But please, when you're in the exam, check your answers. You know, we can all make mistakes. Maybe I've made a mistake with a second one there, but you should check things just because Everyone's fallible, yeah? We're human beings. We're imperfect beings. Okay, anyway, that's enough of that philosophical nonsense. Okay, question 3. Okay, let's do one which is really tough. Yeah, let's just go straight to one which I show people every year. Okay, given that A plus B plus C, I really enjoy this one because it's just quite equals 180 degrees. Yeah, prove that. So this is a proof. Uh, Tan A plus tan B plus tan C equals tan A, tan B, tan C. Ooh. So we're going to try and prove that. That looks a really weird formula. And I sometimes say to students, this, like you've got a sine rule and you've got a cosine rule. Well, this would be the cotangent rule, or just the tangent rule, or just a tan rule. This is like the tan rule for any triangle. It really is. It's really, really similar. Like you get A over sine A equals B over sine B equals C over sine C. Well, this is like a tan rule purely about angles in any triangle. Yeah, because it would work in any triangle, because in every triangle the angles add up to 180. Okay, so we're going to try and prove this. Now, when you prove any statement which starts given that, you should really be using that result that you're given, because it's suggesting that it's not always true. It's only true if A plus B plus C is 180. So I'm going to start by writing down what I'm given, and I'm going to try and turn that into the result they're claiming. Yeah. Now, where do you start here? I think I'd probably start just by taking the tangent of both sides, tanning, if you like, both C plus B plus C equals tan of 180. Now, tan of 180, hopefully you're aware that tan of 180 is 0. Yeah, it's got asymptotes at 90 and minus 90, but it's 0 at 0 and 180. So what we've got here is tan of A plus B plus C equals 0. Okay, so far so bad, really, isn't it? It doesn't really look anything like our answer. But we've got a compound angle once again. So we're going to have to use the compound angle formulae for tan. Now, I know you're thinking, well, hang on, this has got only 2 angles mentioned, but we need 3 angles involved. Well, why don't we treat our A as our A and our B plus C as our B, yeah? So I'm going to use that formula, but I'm going to use A as A, and my B, well, that's going to be B plus C in this question, yeah? So we're going to have tan A plus tan of B plus C. You see what I mean? I'm treating B plus C as B over 1 minus tan A tan B plus C. Now, it might look like we've just made it horrendously complicated, but actually, we're going to times this against 0. So that is not a problem at all. So we get tan A plus tan B plus C. Now, on this, I can use compound angle formulae for tan again. So I'm just going to look at that and I'm going to apply. So tan plus, okay, it was tan B plus tan C minus tan B tan C. And that equals 0 still. Yeah. Now this it's like a black hole. It just sucks away all of the complications. It really does. Now, I don't know about you, but when I'm in this kind of situation, I think, well, multiply by the denominator, because my answer hasn't got any fractions in it. So I'm going to times by 1 minus tan B. I'm timesing the whole equation by 1 minus tan B tan C. That will give me tan A 1 minus tan B tan C plus, well, I've times by the denominator, so this is just going to leave plus tan B plus tan C. And on the right-hand side, I'm still going to have 0, because 0 is just sucking all the complicated bits into it and still producing 0. Okay, multiply out the brackets, and the magic's about to happen, because you're going to get tan A minus tan B, tan A, tan B, tan C, plus tan B plus tan C. equals 0. And so if we rearrange that now, it rearranges lovely, really nicely into the result. Ah, it's not easy writing with these graphics tablets, not my one anyway, which is old and slightly sticky for like if my sweat seems. Anyway, you don't need to know. Okay, which equals tan A, tan B, tan C. Yeah, I desperately need a new graphics tablet. Okay, and there we go. Colour in your little square because you've completed another mathematical proof. Okay, so I hope that shows you how these questions can be nice or they can be nasty. They really can. Have a really good go at exercise 6C. I'm going to give you today's lesson and, both lessons this week, just working through. Firstly, 6B, which takes no time at all, but then 6C, like I want you to spend the rest of the time on 6C. Also, have a really good go at the big trick homework, which I'm setting this week. And please, please, please use the Maths Help Desk if you need to. I'm there, I'm ready, I'm waiting. I'm desperate to hear any voices out there so that I can make sure you're all fine with the work that you're doing. Okay, well done, and keep up the hard work and let me know if you're stuck. Okay, bye bye.